Hello, my name is Graham Ollis. I'm a software engineer at Fastly, an edge cloud platform. That makes us a content delivery network that allows our customers to push logic to the edge, meaning it's, oh. There we go, sorry. Let's see, interesting, okay. Well, this is a bit annoying. Okay. So we're an edge cloud platform, which means our customers can push logic to the edge, means their customers get their responses faster and their backend servers have a reduced load. And I've been asked to let you know that we're hiring, so if you're interested in interesting problems, you should check us out. And now we're on here. Okay, but today I want to talk to you about testing across the language barrier with Platypus. And we'll be splitting this talk up into a few different sections. First, I want to talk to you a little bit about FFI in general and Platypus in particular. I'll be talking a little bit about code generation, unit testing of that generated code, and at the very end, we'll talk a little bit about calling Perl from C. So Platypus is this thing that I've been working on for a number of years, and it's a foreign function interface. So what's an FFI? You know, in the Wikipedia it says it's basically a technique that you use to call into a different programming language from the one that you're using. So calling into C from Perl, for example. But usually when we use the term FFI in the vernacular, we're talking about specifically libFFI, or one of the similar libraries that does the same thing. And libFFI is basically just a C library that lets you call other compiled functions dynamically without a compiler. And libFFI also has this neat feature that it lets you call back into the host language once you're there. And Platypus is the thing that I've been working on for a few years, and it's a libFFI-based FFI for Perl. It's an alternative to Perl's XS. And as you expect, it lets you call compiled languages from Perl and then call back into Perl from those languages. So why wouldn't you want to use XS? So Sawyer also already mentioned that it's not the greatest API out there, but briefly, the terminology I find that is used by XS is a little alien. You know, there are things like SVs and gimme values and X-subs, and unless you're working in the core of Perl, you probably don't recognize that stuff. It's written using the C preprocessor really heavily, so it's difficult to read and to debug. Learning it is time-consuming and difficult. There are a bunch of man pages that you need to read to really understand it. This is one of them, so review that really quickly, and we'll get on to the next slide. Platypus, on the other hand, you don't have a compiler, no problem. You don't actually need it. Recent versions of Red Hat and Debian actually come with packages of Platypus, so you can download those and you can call into your libraries directly without any compiler. You don't have to worry about the Perl guts. You can focus on the language that you're calling into. It's a little bit like writing pure Perl. I mean, it's not pure Perl because you're calling into a different language, but you can put all your code into one script or module. You don't have to muck around with MakeMaker or module build. And compared to inline C, you don't need any temporary files. So I've been working on Platypus for a while, and now every time I see like a DLL, a dynamic library, I kind of think, how can I call into that from Perl? I mean, it's just like my brain is rewired. You know, it's like I see dynamic libraries and they're everywhere. It's really weird. But for my day job, I work on a component that, among other things, generates code. It generates VCL, which is Varnish Configuration Language. It's just a DSL for configuring reverse proxies, basically. So it's really useful if you're a content delivery network like we are. VCL gets translated into C, which gets compiled and linked into a dynamic library, which then is used by Varnish. VCL itself, it's kind of just a normal programming language in some ways. It's got logic and variables. It's also got some domain-specific structures like ACLs. So just as an example, say we have this template which generates an ACL, and we have some IP addresses or masks, IP masks that we want to match and some that we don't want to match. And then we've got a subroutine which, if the client IP matches the ACL, it'll return pipe. Pipe means it sends the connection directly to the backend server. So we're not really that interested in the subroutine itself, but the fact that you have an ACL, and we now want to be able to test this template. This is the generated template. So we've replaced the template with some actual IP addresses and some net masks. So how would you, in Perl, how would you test this maybe? So let's talk a little bit about unit tests. Well, it's Perl, so we're probably going to use regular expressions, right? So here we slurp in the generated code. We sort of get the ACL and we parse out the IP addresses that we're interested in, and we see that they match or not. And there's a couple problems here, right? Because you have to match the exact how the IPs were specified. Like if it's localhost, you have to say localhost. You can't match like a 127.0.0.1. And you can't really match like if a particular address matches one of the net masks in the list. So it's a little limited, but it does test something. And we run the test and it passes. So that's good. So, but another problem is, what if you comment out the ACL, right? Because sometimes you do that, right? You're refactoring code and you comment something out and you have a big test suite, so you may have forgotten this part of the test. I mean, that's kind of the point of a large regression suite, right? Well, it still passes the test. So that's a little unfortunate, right? So what we really want to do is we want to be able to load that VCL in Perl and run tests against the ACL in our test itself. So one way we can do that, remember VCL gets compiled to C, and I can call C from Perl. This is my thing. Again, I see dynamic libraries and I always want to call into them. So I was working on these things for a while, and this was finally my chance to do that. So Varnish has a function that lets you test a match on an ACL. You give it a context. The context is the connection that it's working on. Give it the ACL and the IP address that you want to test, and it returns a true or false if it matches or not. And so now we kind of have the building blocks. We can call that function with our object from Perl. So this sort of builds the ACL object in Perl. But the part that we're, from an FFI perspective, that we're interested in is creating the wrapper around that function. So with Platypus, when you're writing a binding to a C function or another compiled language, you kind of need three things. You need the name of the function, the argument types that it takes, and the return value. And so here, just the Platypus lingo, we use opaque for pointers, and a string should be obvious, and an integer is an integer. And so now we can actually write our testing tools. This is kind of boilerplate. We take in an ACL name and the IP address that we want to match against. We got a test name. And we look for the ACL, see if it exists in the VCL. If it doesn't, then obviously the test should fail because you don't have an ACL with that IP address. If it does exist, then we test the match. If it matches, then we pass, and if it doesn't, we fail. And if you remember in the test, we also had some hasn't calls, so if something doesn't match the ACL, and you can do the same thing, but with the reverse logic at the end. So this is, I'm running the test that I showed you before, and we passed. And so what now if we go back and we comment out the ACL again, the test fails. So that's what we want to see. So the other thing that I wanted to show you was an example of calling into Perl from C. So I've written a library, test2 tools FFI, which is used for testing dynamic libraries, really, but it comes bundled with this library that I wrote called lib222, lib-t2t. It's basically just a wrapper around Chad's test2 stuff so that it sends events basically to the test2 event stream so that you can mix and match Perl tests and tests in C. So here's a real quick example. We've got, it doesn't test anything useful, it just demonstrates the test itself. We have some tests and some diagnostics. Some should fail, some should succeed. We've got a really simple Perl test suite that wraps, a test script that wraps around it. So this one's real easy. The function itself doesn't return any values and it doesn't take any arguments. So we create a function that does that and we call it directly. We run the test and it fails exactly where we expect it to and it passes exactly where we expect it to. And the failures indicate the lines in the C code, the file name and lines in the C code rather than in the Perl code. So that gets included in the diagnostic, which is important for debugging. So, but I want to use this in VCL, right? I want to call a VCL function and test that it works correctly. So we've got an even simpler VCL function. It just returns pipe. When you hand that off to Varnish, it compiles it into this C. And we're not really interested in the body itself, but the function signature tells us that it takes a context object and doesn't return anything. So here we're writing some tests in C that will get forwarded to the test2 framework for us. We're creating a context object, we're running the function with that context object, we're testing the return value, and then we're destroying the context. But from a testing perspective, these are the three things that we're kind of interested in. You know, we use note to send a diagnostic to Perl land. We call the VCL function itself, and then we use OK to test that the return value came back with what we expected. And then we can use more or less the same Perl code to actually call that test function. We run the test and it succeeds. So now we've tested that function. So in summary, We can use Platypus to test generated code, and we can use Platypus to call back into Perl from C. If you're interested in this FFI stuff or the other project that I work on, which is Alien, you should join us on the native channel on irc.perl.org. The other thing is, I just really like platypuses. That's where the name, why it's called that. Actually, I mean, I called it because I like platypuses, but I also liked the idea of gluing weird things together using FFI, and I thought platypus was an appropriate name, and FFI itself was already taken. So that's all I have to say for today, but I think I have plenty of time for questions.
Just to make sure I understand, calling back from C into Perl can only be done from C, so you have to start from Perl and then call C and then you can call back into Perl, or can Platypus also be used as a straight up embedding library so you can have a C main and no Perl functions?
So the question is, can you can call Perl from C, but do you have to call Perl to C to back to Perl? So the answer is kind of, at the moment, you can, but you'd have to, so the simple answer is, the easy thing to do is to call from Perl to C back into Perl. The little sort of more correct answer, I guess, is you can always embed, your Perl interpreter into your C application and then call into it using Perl. But you probably need to do some kind of startup and stuff like that. So there's no reason why, if you have a big C application, that you couldn't have an embedded Perl interpreter and use Platypus to call into it.
Thank you.
So you mentioned that libFFI works with Rust. Have you done anything with Rust using Platypus? And just curious how that works compared to C.
Yeah, that's a good question. So, sorry, the question is, I mentioned Rust uses libFFI as well. Can you do the same things with C? Can you call into Rust, I think is the question from Perl. Sure. So there's some documentation on the internet in general in calling Rust using FFI typed interfaces. I did some simple examples when I wrote Platypus. There's also, one of the things Platypus has is sort of a plug-in architecture so that you can plug in different target languages. So there's one for Rust, one for Fortran, one for, I can't remember now. But since I mostly am calling into C, that's been the focus. And I'm actually, if somebody is interested in refining this, the Rust plugin is definitely available for adoption. So, does anybody else have a question?
Where's Perry?
Where's who?
Perry's a Platypus.
Oh, yeah.
Last question?
Any one more last questions? All good? Okay, thank you.